Assalamu alaikum. Today's our lecture is about a simple harmonic motion that is denoted by simple harmonic motion that is SHM. The definition of simple harmonic motion is the oscillatory motion taking place under the action of restoring force is known as simple harmonic motion. That is written in a red. I have mentioned it like simple harmonic motion is basically a motion that is under the effect of a restoring force. For example, simple harmonic motion. Example of simple harmonic motion is simple pendulum or motion of steel ball in curved dish. In simple harmonic motion, you should know about the definition of restoring force. Obviously, this is all about the dependence of restoring force. Restoring force is the force that brings body back towards mean position called restoring force. The force that brings back towards the mean position, a body brings back towards the mean position, is known as restoring force. After knowing about the restoring force, you should note the conditions for restoring force. To apply restoring force successfully, you should know there are three conditions. The first condition is system must have inertia. Inertia is related to mass. The larger masses have larger inertia and the smaller masses have smaller inertias. Number two, system should be frictionless. System should be frictionless. There would be no friction in the system. Point number three is Hooke's law applicable perfectly. Hooke's law applicable perfectly. Now you should know what is the meaning of Hooke's law. So here is the Hooke's law. Hooke's law, within elastic limit, force is proportional to the displacement. Proportional means directly proportional. That force is directly proportional to the displacement. And when we emit the sign of the directly proportional or proportional, we got a constant known as K. And F is equal to Kx. After seeing all this, now we will have a look on the motion of horizontal mass spring system, that how can simple harmonic motion can affect a motion of horizontal mass spring system. So